these are how our notes are going to work for the next couple of weeks that we are outside of school. I am going to record myself going through the PowerPoint. Now, I couldn't add any audio directly onto the PowerPoint for whatever reason. My computer didn't want to do that. So I'm recording my screen and I will go through the PowerPoint this way, but I will also email you the hard copy of the PowerPoint so that you can go ahead and make notes in the notes section. And so that's basically how we're going to do notes. I won't have a paper packet for you guys to fill in the blanks anymore. I'll just put anything that was important for that slide here, and there might be some blanks, and there might be some questions that you'll have to answer on your PowerPoint, on your editable, did I say that right? On the PowerPoint that you can edit. So this is chapter 1 of physics. It's all about motion. Now, physics was very, very, very difficult for me as an 8th grader. I remember hating it, and I hated it even in high school. AP Physics was literally my worst class. I struggled with it all the time. So when I'm teaching this to you guys, I am going to go as slow as possible so that there's no confusion and that everyone understands. I know with this not being a real class and me not being physically there, it makes it even harder. And some of you guys aren't at the point where you can teach yourselves things. And that's why we're going to have weekly Zoom sessions on different days. And you guys can email me. So if you have any questions as well. So another thing that is going to change is you will not have any vocabulary homework. So let me say that again. You will not have any vocabulary homework. You will not have to write the word, write the definition, and draw a picture for the chapters as long as we are not in the classroom. I still want you to know the vocabulary because, for example, let's look at this one right here, reference point. If you get a question on a quiz on Socrative or a test on Socrative and it asks, what is the reference point in this situation? Is it the tree? Is it the car? Is it the person walking? Or is it the dog? You're going to have to know what the definition of a reference point is to understand what it wants you to identify in that question. So you're not going to have to turn in any vocabulary words, but you still need to know them. So, how would you describe motion? It's going to be kind of weird because a lot of these things I would ask you in class and I would ask you to think about it and I would call on you guys. So when you're listening to me, it might sound like I'm Dora the Explorer, where she asks like, where is the map? And you're like, it's right there. And she says it 3 times and you're like, it's literally to the left of you. I know, just bear with me. I know it's going to be a little bit tough, but this is the best that we can do right now. So, how would you describe motion? Like, how would you describe motion to your little siblings? Don't think about the book definition that is right there for you on the screen. Think about how would you describe motion to someone? Would you describe it as the act of moving? Would you describe it as the act of going from one place to another? Our book likes to say that motion is a state where the distance from one object to another is changing. So, if Mozzie is at a tree and I call him and I say, Mozzie, come here, he should be a good dog and run back to me. And I could say that he is in motion, whereas I could be standing still and I would not be in motion. So that's one example. In the notes section right here, I want you to give me an example of something in motion. And there is going to be a form on OneDrive that will have you fill in some of these blanks. So I'm going to ask you, what did you write in your notes for your example of motion? And you're just going to tell me, or type it in onto OneDrive. So, do you think motion is permanent? Yes or no? If you said no, then you're right. Motion is always changing. That's why right here it says it's a state of being. It's a state. It's not always going to be happening. Now, reference point. A reference point is any object that we can use to establish whether or not another object is in motion. Now, your book gives a clear definition, but I'm just trying to simplify things for you. A reference point is something that you can use to determine if another thing is in motion. So, reference points can be stationary objects. I could be standing in the middle of, let me think of an example. I could be standing in the middle of the elementary playground on a nice normal day where there is no self-quarantine or no coronavirus. And it could be the middle of recess time, or recess if they have that. If I am not moving, I can tell that all the other little kids are moving. I would be a good reference point. You could be like, oh, Miss G isn't moving, but all the little kids are. They are in motion. I would be a stationary reference point. But some reference points could be moving. So, let's look at this picture right here of the car. Your dashboard right here isn't moving. The whole car is moving, but right here isn't moving. And your car could be a reference point for this car, or the car behind you, or the car to your left, or the car to your right. So, this car in front of you is moving faster, or is moving at a higher speed than you are, because it's in front of you and you can't close that gap. Whereas the person behind you, the car behind you, is moving at a slower speed, or moving at a slower amount of motion, because they can't close the gap in between you and them. I know reference point can be a little bit tricky, especially since I can't do any examples and be like, oh, someone come up here and be an example of this. So here is a little nice YouTube link that you might want to highlight, copy, and paste and throw into a search browser so that you can watch it. I know it's kind of little kiddie. I tried to find one that isn't as cringy, but YouTube is a little bit limited. Don't worry about positive and negative reference point or motion. I just want you to kind of understand the gist of what a reference point is. So, measuring distance. How do we measure distance? Actually, I'm going to go back. Sorry. I just want to make sure I covered everything. Good. All right, measuring distance. How do we measure distance? We can do this in a ton of different forms and units. So, right here, give me an example of some units that we use. It could be inches, it could be centimeters, it could be meters, it could be feet, it could be yards, it could be, kilometers. Totally up to you. Just give me a couple of examples. When scientists are studying motion, however, we like to use the International System of Units, or the metric system. So we're going to stick to meters, centimeters, kilometers, and things like that. Don't worry about the Discover activity. That's a fun little race that I used to do in class, but we can't do that right now. Calculating speed. So, all throughout this chapter, we're introing you into speed and distance and time and acceleration calculations, and eventually we'll put all of that together with science and Newton's 3 laws of motion And that's physics. It's when science and math come together. Now, I try to make it very, very simple. So, the speed equation or the speed formula is speed equals distance divided by, that means divide by time. If you know the distance an object travels in a certain amount of time, you can calculate the speed of the object. So if you know the distance it's traveling divided by how fast it's traveling, you can find its speed. So let's think of a really quick example. Mozzie is running 10 miles in 5 seconds. He's a really fast dog. So his speed would be 2 miles per second. That would be incredible. All right. Or you guys are used to hearing this. The speed of a car or a speed limit might be 60 miles per hour. Your distance divided by your time will give you whatever the speed of that object is. So there are other ways to write this. Let's say that you want to find let's do some speed formula examples. I'm just going to verbally say some random examples and you're going to do the math for it. So you might want to pause this, go get a calculator or go get your phone if it's not there next to you, and maybe a pen and paper. And then I will go through a few examples just to make sure we're all on the right track. So I'll just wait a little bit, give you some time. Alrighties, so hopefully you have a pen and paper or a phone, some type of calculator device. So the first example we're going to do. A car is traveling 50 kilometers in 1 hour. What is its speed? A car travels 50 kilometers in 1 hour. What is its speed? So since we're looking for speed, this will be our x. So we'll probably do x equals distance. I said 50 kilometers. So you're going to put 50 km divided